Okay, so finishing up that Ferris wheel problem, we ended up figuring out up to this point. So to solve for h, I would multiply by 30 on both sides um, to get 30 times cosine of 72 degrees t minus 32. So now with negative 32 plus 30 times cosine of 72 degrees t, and then since I need to get h by itself, divide everything by a negative. So it'd be 32 minus a 30 times cosine of 72 degrees, which is what h would be. So how long after the ride starts will a ride reach a height of 50 feet off the ground? So this is the formula. How long will it take? I put a 50 in there. So to solve, now I need to solve for t. So that gives me an 18. I would divide by a negative 30 on both sides. So to get this by itself, right, I have to do cosine of, let's see here, yep, cosine of negative 1 on both sides because those are inverses, meaning like with logs, we talked about them, natural log and e cancel out. Well, cosine and negative cosine will cancel each other out. So cosine of negative 1 of this side equals the 72t, and I would divide both sides by 72. So you get roughly 1.76 minutes, which is about 106 seconds, right? Because 1 minute is 60, and zero point 0.7 minutes, roughly 0.7 to zero point 0.8 of a minute is roughly around 40-ish seconds. How high will rider be 12 minutes after the start? Well, 12 minutes. Put 12 in there, and that ends up becoming negative 0.8090, all that. So negative 30 times that. And we get 24. So when we're doing this, 30 times that. So 32 minus 24.27h. So it's about 7.729 feet off the ground. So we use that formula we found to figure out all the answers. Here's the problems that you really need to know. So you got a rocket and it's fired at sea level and climbs at a constant rate. So here's your rocket. It's going at a constant rate. And we know that the angle, that degree, is 75 degrees. Okay, and we know that it goes for 10,000 feet. We want to approximate the altitude. The altitude is straight up and down. So, to do this, this angle measure that we know, opposite hypotenuse. So what uses opposite over hypotenuse? That's sine. So sine of 75 equals x over 10,000. I'd multiply both sides by 10,000, and you end up getting about 9,659.26 feet. An airplane takes off at a 10-degree angle and a rate of 250 feet per second. So here's my airplane. It's taken off, 10-degree angle, going at a rate of 250 feet per second. Approximate how long it takes for the plane to reach an altitude of 1,500 feet. So 250 t, right? So that's what that's going. That's like the last problem we're talking about, because if the distance is what we're trying to find, the distance is actually equivalent to the rate, which is 250 t. So d equals 250 t. So that's why that went in there. And the altitude is 1,500. So what uses opposite and hypotenuse? That's sine. So it's sine of 15,000 over 250t. So to solve for t, I multiply by 250t on both sides. Then I would divide by sine of 10 and that 250 to get t by itself. So 15,000 divided by sine of 10 times 250 all on the bottom. You get about 345.53 seconds is how long will it take for the plane to reach 15,000 feet. Approximate the angle of elevation of the sun. So here is the person and their shadow. I know it kind of looks like he peed himself, but it's supposed to be a shadow. 5 feet tall and 4 feet long on the ground. And there's the sun. That's sun, yep. So I know that's 5, I know that it's 4, I know that's 90 degrees, but approximate the length, the angle of elevation. So this angle down here is the angle of elevation, and that angle is opposite over adjacent, so it's 5/4. So tangent of 5/4 is 51.34 degrees. So it's 5/4, opposite over adjacent. That's why I use tangent. The antenna is located on the top of a garage. So here's a garage, there's the antenna. I know that from a point on level ground 100 feet away, that is directly below the antenna. So I know the antenna subtends an angle, so that's why this is 12 degrees here. And we want to figure out what that is. At 12 degrees, it subtends means that it's right in there. So I can find out the whole thing if I make the whole big thing a triangle, because I know that the small triangle is 16. I know the bottom is 100, and I just want to find out what that angle is. So in order to do that, I could do tangent of 16 over 100. So just do inverse tangent, because it's opposite over adjacent will give me that angle. So when I do that, I find out that that's about 9.09. So this is 9.09 degrees in here. So that means that whole angle down here is 9 plus the 12, so it's 21.09 degrees. So if I use this big triangle now to try to find out what x is, I know the angle, I know the bottom's still 100, and this is x plus 16 to make that whole side. So figure out what x is. I do the tangent, which is opposite over adjacent, which is why it's tangent of that number. That's the opposite side that was adjacent. Multiply by 100, and then I'd subtract 16 to my answer. So I get about 22.57 is how tall the antenna is. Ship leaves port at 1 p.m. and sails in the direction northwest. Okay, so first of all, there's north, south, east, and west. So we have a ship leaving port northwest at 34 degrees. Okay, north 34 degrees west at a rate of 24. So when I'm talking about a rate, that means it's actually 24 T, that side length there. Another ship leaves a port at 1:30 and sails northeast at 56 degrees at a rate of 18 T. That's what it's going to be. How far apart are the ships? So here's what you know. Those two angles together, what do you know? It makes a 90-degree angle. And that's 24 T. I know that that's 18 T. I want to find the distance that they went. So a squared, b squared equals c squared. So 900 t squared equals c squared. So I square root to get 30 t. So I know that's 30 t right there in between the two. So sine of A would be 18 over 30t. The t's are just going to end up crossing each other out. So that degree right there would be 36.87. So to find beta, I would do 180 minus 90 minus 36.87. So now I know all the degrees. Okay, so at 3 p.m. the first ship left at 1. Right? Let me just see this here. So at 3 p.m. the first ship left at 1, so 2 hours later it was 48 feet at 3. The second ship left at 1:30, so it's 1.5 hours, so that's 27. So to figure out exactly what C was, that means the distance between them was 50.07 miles. Just to find that out. So at 3 p.m., because that's what they wanted to know, this at time t is 2 hours after, and this was 1.5 hours after. That's how far they were at 3 p.m. So the ships would be about 50 feet or 50 miles away at that point in time. So the last part said find the directions of where everything was. So 90 minus the 34 that it was would be 56 down here. So we're just trying to find out triangular wise where everything is. This is a 90-degree angle, but that's 34, that's 56. That's 90, so you can figure out what this angle is now. It's roughly 34. So we can try to piecemeal everything together to figure out the little degree up here. Because if that whole big thing is 90, that's 34, that's 36, that little tidbit in there. You do 90 minus the 70.87. So you can figure out how far it went and in what degree. It went 70.87 degrees east. If you have any other questions or concerns, please feel free to let me know.